Okay, here we are doing lesson 1 of the unit on equations of linear relations. And today we're going to look at the equation of a line in what we call slope-intercept form. Or this book calls it slope y-intercept form, but everybody always calls it slope-intercept form. So we're just going to look at some graphs of linear and non-linear relations. I'm just going to do a sketch of these for you, and you can just copy these down, okay? Actually change that. Use a graphing calculator. No, we don't have graphing calculators, so you're going to copy the sketch of these and do a rough sketch on what we've given you. So this one kind of looks like that. Oops, that's not actually good enough. Sorry, it's got to be not going through the origin there. Okay, so that's a straight line. This is a straight line that kind of goes like that. This one looks like that. Like that. This one's cool. That's an arrow. And this is another one of these. This one looks like this. This one does go through the center. That one is going through the center, the origin there, right there like that. And this one is also cool, and it goes like this. Okay? And then we're going to list which ones are linear and which are non-linear. I'm actually just going to, let's just highlight them. Okay, so the linear ones are the ones that are straight lines. So it's this one, and this one, this one, and this one. And then the non-linears are the, oops, I should probably change the color of that. Let's try that again. These are the non-linear ones. That's definitely not straight lines. Okay? And if you compare them, if you look at the equations of the linear ones and the non-linear ones, I'm hoping you notice that if you look at the ones that are all straight lines, they all have x and y are both to the power of 1. Okay, so this is a cube, this is a squared. That's got the x as an exponent, and this one has got the x underneath, which means that equals y equals x to the negative 1, right? So then what we're going to write here is if exponents on both x and y are 1, then graph is a straight line. Okay, there you go. So we're looking at specifically linear equations in this form, y equals mx plus b. So let's just do some exploring or investigating this. So Janine used a graphing calculator to sketch the graph of this linear equation y equals 2/3 x minus 1, and that's what the graph looked like. And so let's figure out what the slope is. Okay, so the slope is rise over run going from A to B. So it's got 1, 2, and 1, 2, 3. So the slope is 2/3. And the y-intercept is right here. It equals -1. Okay, so what do you notice when you look at those two values and you look at the equation? Well, we see that this number here, the coefficient of the x, that's the slope. And the number the constant here, this is the y-intercept. Hence, slope-intercept form of the equation. Okay, so she's got a graph of 2 more linear equations, and we're going to use the grid to find the slope and the equation. Okay, so the slope of line, let's just color these. So the first one is 2x plus 1, so that's this one. Okay, so my slope is, let's see, from here to there. So 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. So that's 8/4, which is 2. And the y-intercept is right here. So that's, where's my 0, 0? So that's just 1. And then the other one, let's do that in blue. So that's this line in blue. And my slope is 1, 2, 3, 4, 5, and 2. So it's -5/2. and my y-intercept here is -3. So I jumped the gun a little bit. The conjecture is that the slope, make a conjecture about the slope and the y-intercept of the graph and how they connect to this. So m is the slope and b is the y-intercept. Memorize this. The sooner you get this firmly engraved in your brain, the easier life will be in this class. Okay, because that's like the big reveal, the big thing for this unit. Part 2, Hashib used a graphing calculator to graph the linear function 2y equals 5x plus 8. So if we use the sketch to find the slope, slope is going to be 1, 2, 3, 4, 5 over 2. So slope is 5 over 2. And the y-intercept, which is b, is 1, 2, 3, 4. Okay. Now, why doesn't this work? In the previous examples, the coefficient of x was the slope, but the coefficient of x here is 5. And our y-intercept is this constant, but it should be 4. So what's going on? Well, the answer to that is that the equation is not in the right form. Or shape. However, if we write this out and we have 2y equals 5x plus 8, and we solve it for y. So just a quick aside here, if I remember, when you do algebra, what you do to one side, you do to the other side. You do whatever you're doing to the whole side. So if I have 2y equals 5x plus 8, and I divide this side by 2, and I divide this side by 2, well, those 2's cancel out, and that's all fine and dandy. I get y here. But what am I going to do with this side? Well, I have to split this up actually into 2 separate fractions. So the first one becomes 5x over 2, and the other one is 8 over 2. I'm hoping you can see that, because if I asked you to add these 2 fractions here, this is what you would get. So those are equivalent. We're just like unadding them, if you will. So as a shortcut for that, because this is something we are going to do often, if I come down here and I'm dividing this side by 2, I'm just going to kind of skip this step up here, and I'm going to divide this piece by 2, and I'm going to divide that piece by 2. Okay? It's the same thing. I'm just skipping a step because I do it so often it is going to become second nature. Anyway, if I clean this up, I get y equals 5 over 2x plus 4. Oh, which is right. That's what we got when we had the slope and the intercept over here. Okay? I hope that made sense for you. Okay, let's look, continuing on. The graph of an equation in the form y equals mx plus b, or a function in the form f of x equals mx plus b, is a straight line with slope m and y-intercept b. And this is known as the slope slope-intercept form of the equation of a line. And we can draw this without using the tables. So let's work through that. So for this one, our slope is 3 and our y-intercept is 2. For this one, our slope, remember it's always the coefficient of the x, so it's going to be minus 2 over 3, and our y-intercept is the constant, so that's 7. This one here, I can't pull it out of here directly. I have to divide everything by 6. So divide that by 6, divide that by 6. Those cancel out. And I have y equals 8 over 6 reduces to 4 over 3 times x plus 1 over 6. One other thing I guess I should mention is that if I have 8x over 6, that is the same, oops, not that, it's the same as 8 over 6 times x, right? Those are equivalent forms, and you need to be really comfortable floating back and forth between them, okay? Anyway, back to example C, our slope is 4 over 3, and our y-intercept is 1 over 6. Okay, So if you can pull those out of the equation, then it's pretty easy to graph them, okay? Now, before we do anything, we're going to write up in here in big letters, but I'm going to type it. My writing is a little bit abysmal today. So this is my expectations for graphing. Oops, graphing expectations, okay? Number 1, ruler. You must use a ruler. 2, the points used to draw your line must be as far apart as possible. All right, and I'll show you something about that in just a second. And the third rule is lines extend to edge of the grid that you're given to show continue forever. Okay, now you are allowed to, mathematically speaking, if you have a line that goes forever, you're allowed to just draw that little line and put arrows on the end of it. But I'm letting you know that in my class, I'm expecting you to draw them to the edge of the grid. Okay, and that is because I want you to work on being accurate with your graphing. Okay, and that is just an important skill. So that's what I'm going to get you to do. So let me just, I said I'd give you more information about number 2, but I'm going to do that in this example here. Okay, so our slope here is 2. The y-intercept is -5. So we graph this by starting at we have to always start at a known point. So we're going to start at the y-intercept, which is -5. So we're going to start there. And then we're going to use the slope formula, rise over run, to count it says 3 other points on the grid, but we're actually going to do more than that. I want to come over here and remind you that slope is rise over run. So that means we need to take our slope and write it as a fraction, okay? So we want to write that as 2 over 1 so that we have a rise and a run. But we can also write that as, I'm going to do this in a different color, as -2 over -1. Okay, now why do we care about that? Let me show you. If I'm using my positive slope, starting from my point at -5, I'm going to go up 2, so 1, 2, and over 1, right? My rise and my run to here, okay? And my rise, 1, 2, and my run. So I've done, oh, they want 3 other points on the grid. Okay, so 1, 2, 3. So that's what they've asked to do is 4 points and then draw a line. But I want you to imagine that if you put your ruler through these points, or to be even more exaggerated, just if you did your ruler through these points and you were off by, say, 5 degrees, by the time you get out to the edge of your graph, you can be out by quite a lot. It can look great on these 2 points, but at the edge of the graph, you're way in the wrong place. So my expectation is that you are going to continue counting your slope out until you can't fit any more in your graph. So it's going to go 1, 2, and over, and 1, 2, and over 1, up 2 over 1, up 2 over 1. Okay, and then we're going to go back. So back, we can go down 2 and back 1. So that's what the -2 and -1 is. So down 2 and back 1. So my rise is -2 and my run is -1. Sorry, my rise is -2 and my run is -1. And now if I put my line through those 2 points, I'm going to have a really good line. Okay, so that's what I'm expecting you to do. All right, let's just draw this line. So I'm going to go from here, and also make sure that you're chewing your line from the lattice point, not to where your dot is, because your dots can be bad, but you want it to go through the lattice point. Okay, so that's pretty good. Okay, so now I've got a nice line that goes all the way through it. And if I just did it through 2 points that were close together, it wouldn't be nearly as good. Okay? And then you're not going to worry about verifying it because we don't have graphing calculators. Okay? I'm going to suggest that you pause this and try this question. Okay? I'll do it, but go ahead and pause it and then come back. Okay, so the y-intercept, which is B, is 2 over 3. And determine the x-intercept algebraically. So the x-intercept is when y equals 0, right? The x-intercept is when it crosses the x-axis, which means you haven't changed your y value, so y is 0. So that would be, if I've got y equals 2 over 3x minus 6, I'm going to make that 0 equals 2 over 3x minus 6. So if I add 6 to this side and I add 6 to this side, I get 6 equals 2 over 3 times x. And then there's a couple of different ways to simplify this. I'm going to multiply this by 3 over 2. I'm multiplying it by, 3 over 2, by the reciprocal. So multiply it by 3 over 2. The 3's cancel, the 2's cancel. And then on this side, I have 3 times 6 is 18 over 2 equals x. And that means that x equals 9. So I'm going to mark, oh, sorry, back here, I messed this up, didn't I? I did my slope. My y-intercept here is -6. I'm sorry about that mistake. So I've got these two intercepts. So my y-intercept is -6, -6, which is way down here. And my x-intercept is 9, so 5, 6, 7, 8, 9. That's right there. And so looking at this, I actually can't go down another 6 on the graph, so I can't really extend that to do a better line. I'll just have to make do with that. And let's draw our line through that. Okay. And that goes to there. And you are, of course, using a ruler, right? Okay, there we go. So there's our thing. You know what? Let's just double check this. Let's do it. Let's verify it using slope intercept. So my intercept is -6. So I started at -6 down here, and then my slope is 2 over 3. So if I go up 2 and over 1, 2, 3, up 2, 1, 2, 3, 1, 2, 1, 2, 3. Yeah, I end up at the same spots. Okay, that is the end of today's lesson. Go ahead and do assignment questions 1 to 14. Bye.